recording. So everybody can see my screen, I assume. So what we got for you here real quick is a video that we produced in-house. And the guys that you see in this video is actually me and Mike Kleitz. He's the owner of our company. We have a local film crew that we worked with, and it produced a pretty nice little video. So I'll play this for you real quick. It's kind of a quick overview on what the product is and what it does.
They say this is the information age. People want information for their projects and their businesses. They need to be able to understand things, like how much dirt they would need to move for something, or to visualize a construction site. Sometimes they just need to measure a place, and that can be difficult. That's why some smart people invent DB. It's not real big, but it's real powerful. It goes to places that are hard to get to, and it collects information and pictures, even 3D. You can talk to it, and it can talk to you. It has lots of applications it is good for, like planning roads and right-of-ways, even on farms. People who drill gas, dig rocks, mines, use it. But EV doesn't just measure stuff. It can help monitor too, like for the environment and wildlife. Even to help people when there's a disaster. There are many applications for EV. Because it doesn't just give you information, it gives you the power to do great things. What's your application?
So yeah, it's a quick in-house video that we produced there at Quran East. It's something that we did to try to kind of put together a lot of our thoughts that we had as individuals in our company of different applications that the EV product can be used. So a couple things. We've got some new command and control software that offers an exclusive patented piece of technology for oblique imagery. It actually tips the plane into a dive and takes more of a direct photo on the facade of a building, or it could be the face of a cliff or a high wall. What it does is allows us to capture good 3D imagery of
about the drone aerial mapping thing.
Hey George, how are you?
Can you hear me, Chris?
Yeah, I can hear you.
Okay, I didn't realize I had the speaker working.
I'll go ahead and mute you. Okay. Okay, and it tips the plane into a dive and allows you to take some oblique views, oblique pictures, and develop a true 3D model of whatever's there. It's the first time it's been done in the drone business, and it's patented. It's really nice technology, and I'll give you guys a quick rundown of how the command and control software works and how we would pull that kind of thing off. So the program is called eMotion 2. Now, we'll go ahead and exit out of it so we can kind of see what it looks like completely out of the software. Yep. Ask me later. And I'm going to go ahead and connect to the simulator. And this area that we're looking at here is a forested area down in Florida. It actually is owned by a big forestry company that they clear cut a lot of this and I guess retilled it and needed to figure out how much to pay the contractor. And it was just a kind of a neat opportunity to show our wares. So first thing I can do is just to explain the icons here. The software is designed to import Google Earth terrain data. So if we're mapping in hilly areas such as strip mines, Idaho, really doesn't matter where it is as long as there's big steep hills and we're trying to maintain 3 centimeter or 4 centimeter ground pixel resolution, we can bring in a surface model. But since this is Florida, it all shows up blue. There isn't a hill in sight for, well, forever. That whole entire Florida Gulf Coast area is completely, I guess it looks to me to be flat. So I'll go ahead and turn that feature off, and I'll zoom back into where I was, or at least where I think I was. There we are. So to create a flight plan, all we have to do is click on our rectangle over here. It gives us a generalized flight plan. We can stretch this, adjust it however we need fit for a given area. If we want to do a polygon, we just switch our selection to a polygon format, and I can stretch the flight plan around the area that I want to map. All right, and then it generates the flight lines in the appropriate length that it needs. If I want really good data, a lot of times I'll increase the overlap. If I'm trying to generate quality 3D information, I might put it somewhere around 80% and 75% longitudinal overlap. So 80% lateral, flight line to flight line, and 75% of the photo will overlap each one in the flight line direction. So I can change the ground resolution by clicking up and down, and the function of the altitude that the plane is going to fly at is directly related to the pixel resolution that we choose. So if you see here, it says desired altitude. I change it to 4 centimeters, it's at 130. If I change it to 3.5, it's at 113. So all this stuff is being done for us in the background. It tells us that this flight will take 17 minutes and 5 seconds. And if I'm happy with that flight, all I have to do is click the upload button. But in this software, there's a nice new feature for oblique imagery, which is brand new to this eMotion 2 package. It was released about 3 or 4 days ago. It was my first iteration of trying it this morning. So to use the oblique imagery option, we click this photo target feature, and it creates this figure 8 function, which is how the plane is going to fly to capture oblique imagery all the way around the object, and assuming that the object is in the center of this figure 8. So I can move it around. I can increase change the direction of it, and I can change the pitch that it's going to be taken. So if I move it real steep, it's going to take a 50-degree oblique angle image on the face of whatever I've just drawn this figure 8 around. Pretty nice feature. I've not had an opportunity to use it in real practice, but I know what the benefits of it are, and pretty neat for trying to get a 3D view of whatever might be on the ground. And I'm not referring to stockpiles or natural ground features, but I am referring to maybe a silo, maybe a prep plant, maybe a structure of some sort, whatever. So this is how we pull that off. And again, it's brand new to this software. Pretty neat feature. You see here it has the pitch angle at 35 degrees. It actually puts the plane into a 35-degree dive to take that photo. It's not going to climb at 35 degrees. It's going to dive, which is pretty neat. So to pull the flight plan off, all we have to do is simulate. I'm going to simulate the launch. And while I'm doing that, I've got a simulated motor error. Oh, wow. How do we get rid of that? I know how we probably get rid of that. It says it flew into the ground. Amazing. It simulated an error. I'll click this and upload. And all right, disconnect. Okay, reconnect. Click on this rectangle. re-upload the flight plan to it, and launch the plane. Wow. Okay. Amazingly, we have a simulated error in my flight plan, which is baffling. How you can end up getting a simulated error. PB simulator. Okay. We'll move on from this part since it's not working properly. But that's the new version of eMotion 2. It just released. I haven't had an opportunity to try that process in practicality, but it's pretty neat. So also with that came a new version of eMotion 2 Post-Flight Terra 3D post-processing software that we've been anxiously waiting on. And I'll pull it up here real quick. Some of the nice new features about Post-Flight Terra 3D in its latest revision is it allows us to do some vegetation processing, but it also shows the data processing in real-time 3D. So I'll open up it's coming open here. Tells me I only have 100 gig of free hard drive space it needs.
Hey, Chris, this is Rocco. I just joined in over here in New York, so.
Okay, cool.
Along with Jeremy, I just want to say hello.
All right, thank you very much. And here's the flight that we did down here. So it was on a reclaimed strip mine site. And what's pretty neat about this new version of software is if I go here under my processing options, I can choose whether this is an oblique project, an oblique image project, if I'm trying to separate trees from the ground. This is a pretty nice feature. I actually have some data that I processed this way for the South Carolina Aviation Administration that was trying to determine how much tree they need to remove from the end of the runways. I guess they have to have a certain projection or projected clearance that for aircraft leaving the end of the runway, and this was a pretty nice feature for their benefit. Point cloud densification, we can choose based on the size of the project how much of the imagery that we want it to use. And our orthomosaic generation, it gives us a bit more control over how our 3D surface is being calculated. And that's a pretty neat feature, and it's almost just a statistic that we have to play with when we process on big projects. And it'll also create a Google Map KML with all the photos that'll be geotagged in one great big Google Earth KML. So and our prior version of Post-Flight Terra 3D, we had some issues with the software not liking to work in US feet. This is a Swiss company, and I guess 97% of the world likes to work in meters, and here in the United States we're still working in feet. So with the latest revision of software, this allows us to properly process in feet and have our imagery rectified correctly. So pretty nice. So I'm not going to sit and probably, processing takes quite a while to pull off. I just kind of wanted to show for current users the new bells and whistles that are in the software. Again, we're getting oblique imagery in our newest version of software. We have a Google Earth interface with our command and control software that actually shows our plane over top of terrain in 3D while it's in flight. And in the newest version of post-flight that allows us to apply some vegetation filters to our algorithm that's being applied to the photograph. And it also gives us, under the Ray viewer, an opportunity to look at the data being processed in 3D. It does have some functions for volumetrics inside of this software, but it's not great. It's not. I'm not even going to pretend to say that it's great, but it's in there. It works in meters. I don't like to process jobs in cubic meters, so I'll go ahead and leave there, and I'll start pulling up some data that we did, just so those that haven't seen it have an opportunity to do so. All right, let me reduce this, and I'll pull up Global Mapper. So what we're looking at here in Global Mapper, this program called Global Mapper is basically a low-end visualization program that allows us to open LiDAR, large orthomosaics, and overlay them in different views. It'll also contour. It'll also convert. I'm sorry, I clicked too quick. Now I have to start over. I'll open it up. Not a valid license. Thank you. Here we are. There's our point cloud that we did of the Barbersville soccer fields. This is an RC field close to my house. Pretty remote area.
Still snowed in, Tater?
Hey, Doug, everybody can hear you.
Sorry.
Yes, no, I'm not. It's 47 degrees here.
Cool.
So these are some soccer fields here close to the house, and what was neat about that vegetation filter that I showed there in that prior version of Post-Flight Terra 3D, if I zoom in here a little bit, there's a trail that runs along the side of the river here. And, oh, I'll have to zoom back out. We'll see it in this view as well. There's a trail that runs through there. It's a mountain biking, running trail. It's a pretty nice little spot. But what I thought was pretty neat about it is where the software used to take the least path of resistance in the point cloud generation. And when we would get into areas like this, I mean, it's highly vegetated. It's in the woods. But we can actually see that mountain bike path running right through there, and you see all the bushes and trees above it. This is a point cloud that was generated from the photography. So rather than having a truncated surface where the software took the least path of resistance, we now see something that represents what's really there. I mean, you can see the branches and the trees, the body of the tree. If I zoom over here just a little bit, I'll see if I can see it in this picture. There's no soccer goal there. I'll zoom out. And I'm also pulling this off of a hard drive as I'm going. So if it, here we go. There's a soccer goal. Right there, I see a soccer goal. And again, it would never pick something up like this before. Now we see the soccer goal in there. So the processing software is getting better and better and better all the time. Again, this is a point cloud that represents what we see out there. And I have some views of some trees here that might be handy. Seems to me like I talked to somebody the other day that again was going to be working in canopy forested areas that being able to distinguish between trees and ground was kind of a big deal. So I'll go ahead and kick this little area in 3D, and we'll be able to get a good picture of how it processes tree canopy now. And this is all with the latest revision of Post-Flight. We couldn't get these kind of answers before out of the first version. So, you know, even from a distance, you can kind of look at this and see that how this is being rendered is a pretty good representation of trees. I mean, you can see, obviously it's not going to see underneath the tree, but it's seeing the top of it, and then it sees the ground right beside the trees. This is brand new to this software. If you haven't been able to use Post-Flight Terra 3D and you're just getting into it at this point, you're really getting a lot nicer piece of software. So there's a, oh shoot, there we go. There's a bit more of a picturesque landscape of what it looks like. You can see the trees, you can see the other trees out here in the distance. And I don't want us to waste too much time on this example, but it is a good example of what the new processing software can do. But we have a rail overpass right there. So before, it would take the bridge and it would plaster it right to the ground. You wouldn't be able to see underneath it. You didn't have a good idea of what was really there. So if I grab this bridge and I go ahead and kick it in 3D, okay, here we go. You can see the bridge a lot better now. This is a walkway going across it, this little area through here. And then there's the bridge. And, of course, there's going to be an empty spot underneath it because it is a bridge, and the plane can't see under. Maybe if I did an oblique shot on it, it might have been able to if I'd have had that technology at that point. So, again, the technology's gotten so much better with processing orthos and converting them into 3D. And this is just a good example of where we're at, what we have available now. So I'll go ahead and dump this data. We've done a couple more, and I know I have some mining customers on the line. So I'll open up some mining data that we have done close to home. Hopefully my eyes don't fail me here. Feel like I go blind in files. Okay. Hey, Pete Orbovich.
For some reason, it's got me signed in as Pete.
Is Pete not on this?
I don't believe so.
Okay. Here we go. This job was not done with the newest version of Post-Flight Terra 3D, but it is pretty nice. This is a reclaimed mine site down in Pound, Virginia. Then kind of right smack dab in the middle of nowhere. And here's an overview of the whole site. It's a pretty big area. You can see a ridge running across here. Again, this is all reclaimed ground. You can see some watershed. And if I zoom in here a little bit, you'll even see where the water has run off of the ridge line, I guess an erosion effect. So if I open up the orthomosaic and superimpose it, so now we're looking at a view of the ortho superimposed on the surface. And I mean, this is 4-centimeter resolution. I'm going to move over here a little bit. You'll see us all standing around. You can see all the vehicles in the surface as well, which the newest version of software gets rid of when you process. Yeah, you see all of our cars and kind of get an idea of the resolution that we're getting while we're out there. I mean, you can see the folks standing around plain as day. Just the photo quality of the overall orthomosaic is very crisp.
What
It's really
altitude
good.
was this flown at?
What's that?
What altitude was this one flown at?
This was 4 centimeters, so 130 meters over takeoff, and I enabled that feature. I don't know if you were part of the presentation where we showed how to import the surface data, like when we do our flight planning, where it'll maintain 3 centimeter or 4 centimeter pixel resolution through its whole flight. So the plane, as it flew over this ridge, that long ridge, it actually lowered itself. So it was done at 4 centimeters, but it maintained 4 centimeters coming down this ridge line, if that makes sense. So I did the flight plan with the gradient of the ridge line. So I'll zoom in a little bit closer here on some more stuff, and we'll just get an idea of the quality of the 3D data that we're looking at, and then I'll drop some contours on it. So here we are. Again, looking down the ridge line, you can see our vehicles off there in the distance. There's the ridge line, and it turned out really good. You can see all the windrows left over from the dozer, or maybe that's erosion. I don't know if that's windrow or dozer. I can't distinguish between the two. Since this is a reclaim job, I'm going to say it's windrows. And I'll pan over a little bit and just kind of give us a little better view of what's there. So it really does a nice job on 3D mapping, especially whenever you've got a lot of change in elevation. So in just global mapper, not to really toot its horn too much. I'll just do the data that's on the screen. I'll do 2-foot contours. If this is going to take a while, I'll cancel it. I've contoured this thing about 50 times. Does anybody have any questions at this point that I haven't addressed?
What's the contour accuracy?
Well, the contour accuracy is generally, from my understanding in surveying and engineering over the years, has been you can contour at twice the grid interval that you have. Am I correct? So if you...
That's what we use.
Yeah, so at 4 centimeters, I've got customers doing stockpiles at 1/2 foot contours. So I'm going to say that the contour accuracy is going to be pretty good. This wasn't tied to any ground control, by the way. Our typical jobs where we tied them to ground control, usually if we hover over the ground control point and look at the surface once everything's calibrated, we generally get it within hundredths of a foot. But it's the accuracy that we're looking for is in between the control points. So we have to take a level or a total station or a GPS system and do intermittent spot checks. And we're generally coming up with about 15 hundredths of a foot in our vertical ties.
Okay.
So Chris, if we're not using ground control, what are we relying on for our relative accuracy then? The GPS on the...
Well, yeah, right. That's it. It uses the GPS coordinates of the first photograph that's in the ortho. So the whole map is going to be accurate relative to itself, but to state plane, it could be, 10 feet.
Okay.
So ground control is always a great idea. And my typical procedure for ground control is I'll go and take a can of pink marking paint. I see pink marking paint better than orange. And I'll paint a 4x4, just a cross on the ground, a big X, and take my my rover and just take a shot on it. So I'll go around the site, and I try to do it in a dice formation where I've got points on the outside of the project and a couple in the middle. And when we do it like that, we're getting really, really, really good results.
And we don't have to really concentrate on getting multiple points in each image because the images, we're going to have to concentrate more on multiple points within the mosaic.
Right, multiple points within the mosaic, and the more photos that you have of that one individual ground control point, the more accurate the whole ortho becomes. So if we fly at a 75% overlap, we're generally going to get about 15 pictures of that one ground control point. So it's not hard to ground control calibrate either. It's just It's tedious. It's like typing in a Traverse longhand.
Chris, are you able to save
We certainly are going to have images.
I'm sorry.
Are you able to save a contoured view? Do you have to run the contour every time to get a contour view?
No, I can save the contour view, and then once the contours are generated, I can save them as an AutoCAD DWG, a MicroStation DGN, or a DXF file, a shape file. So once I've got it contoured, I can send it to whatever CAD format that I want, or whatever format that I want. Or I can use the point cloud that I generated. I think I was just showing a point cloud, but I can use that same point cloud information. The software generates two separate point clouds, one of them on a pixel by pixel generation. So it creates a point cloud point for every pixel in the photo. And there's another dumbed down version, if you will, of the point cloud that's 100 centimeters. And on a job like this where we're looking for ridge line and grade breaks, on a really dense point cloud, it can make your contours a little jumpy. So if we use that 100 centimeter version, it makes everything a lot more fluid, if that makes any sense. So there's a couple different ways we can skin the cat with topo jobs like this.
Okay, thanks.
So this is almost done. It's got about 2 minutes. I don't know if I should wait on it. I guess it's already close enough. And you know, I notice he's on the call here. Hello, Dr. Post. We have some colleagues that we work with, where as a company we're trying to better ourselves as professionals in many regards. And we have a friend down from Clemson University on the call, Dr. Chris Post. He is a professor. I guess his specialty is remote sensing.
Yes, it's a GIS and remote sensing, and I thank you so much. I'm really enjoying the presentation. I heard about the new features, but it's exciting to learn about the new features, especially the vegetation stuff and everything like that.
Yeah, I'll get you that. And if there's whoever's a user on here, if you want the new version, just drop me an email and I'll find a way of getting it to you. It looks like it's almost done.
You said this global mapper was approximately $400?
It's $450. They raised the price with the new version 15. But I mean, look what it just did. I mean, without having to drop it in AutoCAD, I just contoured this whole area. And now that it's contoured, all I got to do is, and it'll also reproject it. This job, it assumed UTM metric coordinates for its GeoTIFF. And I can reproject it to NAD83 or NAD27 or whatever I want it to be. I can raise the surface. I can lower it. So if I need to manipulate the data more, it just allows us to do some pretty snazzy stuff with it. So if I want this to export as a PDF file, I can send it out as a 3D PDF file even if I want. But mostly what I do is just go right to vector. I'm going to send out I'm a CAD guy. So I'm going to use DWG, but if I was a MicroStation guy, I'm going to use DGN. And if I'm one of those flaky GIS people, I'm going to convert it to shapefile. I hope there's no, I just tease about the GIS world, but DWG is what we're looking for. And then I can just save it as a CAD file and then bring it right into AutoCAD, Civil 3D, Carlson, whatever we need. So you can see here it's a pretty nice looking topo. A $450 piece of software just took about 6 gigs worth of data and made a topo out of it. So it's a nice package for what it is. So there's a mine site, and I always like to show the stockpiles. So I'm going to unload this section, get rid of this data. I think somebody was asking me if I could save this. I can save this job. I can call it, I probably don't want to put it in there. So, you know, I can recall it and all those lines, everything will show back up the next time I open it. So if I dump this data and manage to not lock my computer up in the process.
Now, was this one created using the point cloud that had one for every pixel, or was this one used for every?
Well, I actually used the GeoTIFF. I actually used
Okay.
the GeoTIFF in this instance. I didn't use the point cloud. I don't know why I didn't, because I guess the surface was already made. Global Mapper will not contour a point cloud. It'll only contour a surface. So I could have taken the
Okay.
point cloud and put a surface on it, and then contoured that, and everything would have came out really good. So if I go
Okay.
up here to my documents, man, down here, there's a quarry operation that we did up in Maryland. So I'll go ahead and open the surface file of it again. This is just another nice feature of Global Mapper, is volumes. Well, this must be pretty big. The wind this day when we flew was awful. There were 30-mile-an-hour gusts when we flew this quarry. There's the surface file, and these are sumps. Just before I open the picture, this is a sump pond, and if you happen to ever fly over water where water is dynamic, key points from picture to picture aren't necessarily the same. So you end up with water that looks kind of like at high tide, even though it's dead calm. I'll open up the mosaic. And there's the picture of the site. There are the sumps. There's some stockpiles here. And we've got stockpiles here and we've got stockpiles here. So I'll use this area. And then I'll use that other area next. And the reason why is for high wall mapping. I don't know if anybody needs to do high wall mapping, but it does a pretty good job. And this is an unusual pile too, because this is something that we would see typical in the coal industry is maybe a raw pile where a loader has brought all this in and dumped it, or at a quarry operation where a truck or another loader has come and dumped it. So when we go to do volumes on it, the conventional way with a GPS system or a total station, a lot of times it's real hard to pick up the break in the valley of these little parts of the stockpile, where in our aerial image we're picking it up. So I'll go ahead and kick this in 3D just to show us that we are. I'll zoom in on it. I'll exaggerate it a little bit just so we can kind of get a picture. So it's picking up all the lumps and bumps and the little valleys that are in the stockpile. So it's going to give us a pretty good picture of what we have after the fact. So all this, the neat thing is all this data is real. It's not, wasn't given to us. We don't have any other data. So if I draw a line around this using my little measure tool, again, this is the old-fashioned way of doing stockpiles where you just assume that the thing is sitting on flat ground. If you had a base elevation or a base line for the stockpile or a surface that maybe sits underneath it, we could have actually imported that. So I right-click, and all I have to do is say measure the volume. I want to do it inside of this line. I want it to report it to me in cubic yards, and I hit OK. And then it gives me a volume. So there was a little bit of gravel below that baseline that I drew around that stockpile. 3 cubic yards compared to 1,673 cubic yards is pretty insignificant. But just like that, probably a 20-minute flight, about an hour and a half's worth of processing time. We're doing volumes on this gravel pile. So yep, I want to cancel that feature. Now I'll move over to the high wall part of the job. And grab the hand and pan over. The oblique
Are you
imagery.
seeing a lot of demand for this in the mining applications? I know they normally sell a lot of this stuff by tonnage more so than volume.
For volumes in the mining business are a pretty big deal. I mean, I guess that's all I kind of know is that every month, at the end of the month, they have to have a pretty good picture of how much coal they have sitting there. So they weigh it as it goes out, of course, but they always kind of have to know how much coal they have there. So the application is pretty big deal.
Okay.
I've got a mining guy on here. I hope he's listening. I'm
approaching this all from civil topography standpoint, and I'm trying to see what other revenue streams I can generate, and that seems like an exciting one right there.
So I'll go ahead and dial down the exaggeration on this high wall data and kind of explain it. So here we are again looking at a stockpile. We're seeing a haul road go up around here, and on that haul road is a safety berm. And then we have another safety berm, a ditch. We have high wall. And whenever we flew this site, I had no idea that this thing existed or even what it was, if it was a pile of dirt or, looking at it from a 2D view, I don't know what it is. And I can almost imagine that the oblique imagery option, if I could have had that feature then, I would have had a lot nicer view. We probably even would have been able to quantify the thickness of various seams of rock going up this high wall. But there we are looking at that picture of that high wall. So I'll exit out of this view, and I'm going to go to my cross-section view, and I'll start right down here at the road. I want to cross-section all the way up here to the very top. So there we are. We start down here on this road. We come up, jump up the high wall, hit a safety berm, cross the road, ditch, up the face of the high wall again, and we have a flat spot. Of course, I didn't bring that ditch into the profile. I wish I would have. I will. I'll do it this time. So here we are again. We have our safety or our berm, ditch, high wall, big flat spot, and then now we hit this ditch right here. That was actually a ditch. I didn't know it was a ditch whenever we flew it. Or even after I looked at the ortho, I didn't know it was a ditch until I overlaid it on the surface. So a pretty decent thing. I mean, knowing how windy it was that day, it still turned out really good. Which I've never found good weather on any quarry or any mine site anywhere on the face of the earth. I've never been on a pleasant day where it's 74 degrees with light wind. It's either 100 degrees with no wind, or it's 12 degrees with 60-mile-an-hour winds. So pretty good example of being able to pull off some nice profiles. There are some display options that we have. We can export this guy. We can change the exaggeration on the profile. We can do some calculations. So, a lot of neat options inside a global mapper. I mean, this is just a nice throughput tool that we offer at our company, and we really started offering it just to be able to re-rectify data from UTM over to NAT83. And we don't need it anymore for that, but it allows us to export contours or whatever over to AutoCAD pretty quickly. Even as a point cloud tool, it's a pretty inexpensive point cloud tool. So I'll go ahead and exit out of that. Anything else in here somebody might like to see? This is a pretty typical site. This is not a special one. It's just one that I've used a few times and kind of know where things are. Some other stuff that we offer at Quran East that started becoming kind of new to us. I'll try to explain the benefit of it, especially if you've got field data collectors or you're exporting orthomosaics to different software packages that might not have enough horsepower to process one of these guys. So if I find that Lafarge folder, here it is. That orthomosaic is just a picture alone is 346 megabytes. So if we wanted to take this information and send it to our handheld GIS data collection platform, maybe a machine control box, a survey grade GPS system, whatever the case may be, it's going to kill the RAM of that collector. So we have GeoExpress, a program from Lizard Tech. I'll pull it up here real quick. GeoExpress 9. So we're looking at the full-blown image right there, and I even think with the DMME data that I showed there earlier of that reclaimed mine site, it was pretty high-resolution data. So I'll go ahead and do that. I know it was on my hard drive, so I'll just go right down here to my hard drive. I'm going to go to the DMME folder. I'll pick the bigger of the two. Right there. And I have a compression ratio option that I can choose here. And there are some other tools that we have in here. If I want to reproject this picture from whatever coordinate system it is, it says UTM zone 17. If I want to reproject it to NAT83, all I got to do is reproject it to NAT83 just by selecting the coordinate zone. But I'll just go ahead and compress it the way that it is. It's going to go to my hard drive. I don't want to compress it by a ratio. I want to make it a certain size. And I'm going to assume that I'm putting it on a handheld, whatever Topcon GRS1 GIS grade data collector. So I'll go ahead and compress it down to 3 megabytes from input image size. That's with the black area included, 687.6 megabyte overall size. So I'll say execute. It might take it about 30. Well, it says it's going to take it a minute and a half. And there's also a Geo Viewer for the iPhone and Droid platform. It's a free viewer. So if you're a construction company, for instance, or maybe a fruit grower or a timber company or a corn farmer, whatever the case is, we compress this photo down to a couple megs, 3 megs. Somebody can email it to you. You can open it up on your iPhone and use the GPS in your iPhone or your Droid GPS-enabled device and see yourself on that orthomosaic, see your GPS position as you move across it. It's a free program from Lizard Tech. You can go to your app store and download it. It doesn't cost anything. $16 seconds. All right, it looks like it's finishing up. All right, it's done. So now if I go back to Global Mapper, I can unload all this data and go back to, I believe it's on my external hard drive, and go down to the DMME folder. Mosaic. Here it is. 131. Here it's coming. So again, there was we saw a second ago, I zoomed in and found us on the map, the people standing around. This image has been compressed to 3 megabytes now. And you can see just based off of the elevation that we're doing our flights at, even compressing it from 687 megs down to 3 megs, we've lost a little resolution, but putting it on an iPhone and being able to use it on multiple platforms is a pretty nice feature overall. So we've lost a little resolution. You can see a little grainy effect to the photo, but it's still better than anything that you'd ever be able to download online. And I could email this, and you could open it on your iPhone and walk around out there and see yourself on the photo and take measurements and draw polylines or whatever needed to be with whatever device that you have. So there we are looking at a compress from 687 megabytes down to 3 megabytes. Is there any questions right now? Any other data that I might be able to show that's of benefit to our audience today? No? Wow.
I assume you and I are going to go over this in depth on Tuesday?
Oh, yeah. Yeah, is this Derek?
Yeah, it is.
Yeah, Derek, if you even, like afterwards, if you want to sign on again, I can go through are you using this newest version of eMotion 2?
Yeah, I just downloaded it yesterday.
Okay. Yeah, I mean, I'd be happy to even go, if you want to do some test flights over the weekend, I'd be happy to even go through it with you this afternoon, just the command and control software, if you like, just so you feel comfortable with what you're doing before you do a dry run somewhere.
I'll probably wait till Tuesday so all my business partners can be there for it as well.
Oh, yeah. Okay.
But I appreciate it. So,
anyhow, I don't know what else I have to offer to this online forum at this point. We have current users and we have prospective users all in one group. So if anybody has anything that they'd like to cover or any questions that you might have, just by all means speak up. And if I didn't cover it in this,
so Chris, yeah, Chris, this is Jeremy. I'm out here with Rocco. And anyways, I jumped on a few minutes late, but one of the couple of questions I had is capacity of the unit. Mm-hmm. What is the onboard capacity, and is it upgradable? So in other words, how much onboard memory do we have?
The onboard memory of the plane is enough to do about 20 flights. The memory on the camera, there are two different things. It's just a little Canon digital camera, and quite frankly, I mean, we've got Derek on the line. He just got his. He probably looked at that camera and he might have stomped his fist on the desk. It's an $80 Best Buy camera. But
okay.
No, I got the NIR.
Oh, you got the NIR.
Mine wasn't $80.
Well, if you look at
it looks like a little one. It looks like a little Canon CyberShot.
Right.
You go out and buy.
Except for
it came with a 16 gigabyte internal memory card.
Right, which you can upgrade to whatever you want. So it's just the one that it comes with. So keeping that in mind, that little wire that you see on there is what you're paying the big bucks for. So Sensefly retrofits all these Canon cameras with a USB interface, and the camera is triggered by the autopilot. So the autopilot tells the camera when to turn on, when to take a picture, all that good stuff. So the memory on the camera is upgradable, if you want to refer to it that way. They come with a 16 gig card. I couldn't imagine filling one up. I use a 4 gig card. So as far as internal memory on the plane, as far as long flights go, you're not going to kill it in a day's time or even 2 days' time. But the memory on the camera, if you fly it all day, you'll actually run the battery on the camera dead. So you'll run out of camera battery before you run out of memory card.
Okay. So, and then what if we're going to do, let's say, I'm just going to use like 1 square kilometer. How much data how much data is collected off, and I think your average, you said 3 centimeter. So just kind of give me a baseline of how much data we would, accumulate over a flight.
Over a pretty good sized flight, I did 1,000 acres last week, and it had about 800 pictures in it.
How long did it take to fly 1,000 acres?
It took us 6 flights of about 25 minutes apiece.
Okay.
And ironically, I've done a 3 square mile flight in 40 minutes. I don't know why it took me longer to do that. Probably, I know a couple reasons why. Then you always look at a project and know you could have done things differently when you did it. But looking at it, the way the project was shaped funny, it wasn't a big rectangle, it was shaped funny. So we had a lot of short runs and a lot of turns. And we set our overlap a lot tighter than what we normally would have because it was forest ground. We wanted to make sure that we got everything that was there. So, you know, typical file size on a great big, you know, you said 1 square kilometer.
Mm-hmm.
That's going to be 3,300 feet by 30. I really don't have a good number for you. I know it's, you know, the park that we were looking at, I'm sure was
Right. So let's just use your numbers. So we had 1,000 acres, 800 pictures, 6 flights, 25 minutes per flight.
Mm-hmm.
What overlap were you using on that?
That was that day. It was 75% by 65% longitudinal.
By 65.
And it came out really good. I don't know if I have it on this. I know I have it here handy. Bear with me. I'll pull it up and show it to you.
Okay, and that was without the oblique, right? So
Yeah, that was just standard aerial imagery.
Can you do multiple obliques in one flight in a single area?
Yes, you can.
So yeah, because our application is mining exploration, so that's why we're trying to get a handle on this.
I got you. So this right here is 1,000 acres. The area, I drew a polyline around it and measured the area, and that is 1,000 acres. And you can even tell that they were flown at different times of the day.
Sure.
You see that?
Yep.
And this has also been compressed down to 15 megabytes using Geo Express by LizardTech. So this was flown at this area, the darker area was about 7:30 in the morning, and the area you see above there was in the afternoon. So we flew it in the afternoon, and then we came back in the morning, and I think there was 2 more flights. This darkened area is 2 flights.
And what elevation were you flying at for this?
We were doing 4 or 4.5 centimeters, so it was a little over 130 meters at takeoff. So about 390 feet.
And did you use ground control for this?
No, we did not.
Okay.
It wouldn't have made a difference in the time that it took us to fly it.
Right, right.
And realistically, it wouldn't have made a difference in the time that it took to process it either.
Right. And then, so I kind of caught just a part of that. So you basically base it off your first flight with your first image. Is that correct? And then and all the other images are based on that? Right.
It just seams everything together using a bundle block adjustment. So it goes through looking for key points from photo to photo, and it seams everything together. And the coordinates that the thing started from are solely based off of the first picture.
Okay. What was the name of that mobile app again? I didn't catch that.
GeoViewer.
GeoViewer. Okay.
It's by LizardTech. Yeah, it's free.
By LizardTech. Okay.
Yeah, if you want me to send you a sample of
yes, I would love that. I was hoping that we could. I don't know if we need to do that online here, but I'd like to get a sample of that.
No, I've got Rocco's email. I'll just forward one to him.
Right.
And
yep. Anything else?
In eMotion 2, is there a way to change everything to English units to feet and miles?
I heard there is. That's a good question. Let's open it up and look. Nothing like the imperial units to make sense out of the world. I've been using meters long enough to know. EB simulator, simple. Okay. So if I go up here to preferences, user interface, local preferences, laptop, metric, imperial. You see that there?
No, my screen's catching up. Hold on. Can you go through that again?
Yep.
How'd you get to that preferences one?
Right here at the top left, the little folder.
Okay.
And just to explain a couple of things while we're in here, if you go to preferences, okay, this is brand new, and you go the very first option, says select language. Obviously, you can do English only. Interface is going to be a laptop. And if we want metric or imperial units, of course, are feet and miles. Do we get that?
Yep.
All right. So imperial units. That's new. That's new. And if I have if I've flown something in the strip mining world, this would kind of be a big deal. So if I've flown it already, and I already have a surface built on an area, and I'm going to fly it again, and I want to make sure that I'm maintaining that 3 centimeter pixel resolution, instead of using Google Earth as our map set, we can import custom elevation data. And is this in Florida? This is in Florida. Let me find my folder here for it. Post-flight, Terra, here we go. I can actually use the, you see that? That was actual flight data that I did with them. That's the actual surface file, the blue in there.
Okay.
I brought in all the surfaces that the software generated off of that flight that we did for this company. But of course, it's all flat, so it's not serving us any purpose. But on a construction site where maybe the whole top of a mountain's been taken off, we can import our first flight data, our elevation data from the first flight, and actually use it to do our surface calculations to maintain our proper flight elevation for our next flight. So you see here, all of our data is now showing up in feet. We got knots as our speed. We've got ground sensor height as elevation is in feet. Our airspeed again is showing in knots, and our altitude is showing up in feet. So thanks for asking. I'm glad I showed that to you, or else I would have forgot to check on it myself. There is a flight data manager in here as well. And what this flight data manager does is you have a calendar. So last, I guess it's showing me, I flew on the 20th and I flew on the 21st, and it's showing me the flight areas here, the polygon. And it's saying there were 44 pictures in this flight. There were 197 pictures in this flight. So, and I also did 2 flights that day. One had 199, the other had 197. So if I wanted to go ahead and create a project there, all I have to do is type in a name. And if I have my drone hooked up with a little USB wire, and I have my card in the card reader on my laptop, all I have to do is hit the next button, and it'll automatically import all the pictures. It'll geotag them, and it'll create a post-flight Terra 3D project all in one fail swoop, if you will. It creates all the, you don't have to think, or you don't have to match dates up with flight logs. You just simply follow the next routine and bring the data in. So I did this, and I know I've got all the data here. Like here's Foley, here's flight 2. There's the flight log. And then it'll ask me to do the pictures next. So every one of those red dots represents where it was supposed to take a picture. And Of course, this new version, I don't know how to find. Image matching is not optimal. Please check. Probably because I picked the wrong flight with the wrong picture folder. If I had my card hooked up or plugged in the computer and I had my wire hooked to the plane, this would all be automated. There wouldn't be any. You see how the flight's up here and it's expecting it to be here? Down below? Okay. So this is a pretty nice feature, but what's really nice about it is it also creates a Google Earth KML of the flight. And I'll
yeah, I was messing around here watching the EV fly around on Google Earth with a live update. That's pretty neat.
Well, yeah, that also shows you the live update in Google Earth, but what it does here after the fact, let me today, spread this guy open. It creates a KML and it geotags every picture. So you can actually see what we flew, and this is an after the fact deal, okay? So now I'm looking at it in 3D. You can see how the plane came in and landed. And every one of these white golf ball looking tee things is the picture that it took, and it's geotagged. So if you're trying to share this data with somebody that's relatively simple, you just have to email them the image folder and the KML, and then they can click on every one of those golf ball thingies and say, oh, looky there. There's that picture.
Okay.
So it's I guess maybe I think things are way neater than what they really are. But pretty neat feature of the software. You know, any of the T's that you click on, it'll give you directions to it because you can tell it's geotagged that way. So there we are. Any other questions? Anything else I can add to the big picture? Here's if anybody likes to process in software different. I should have opened this with a different piece of software. We have some Trimble users that are heavily bedded in Trimble, and it scares them to death to use a different piece of software. Only flight 1. I'll change this to a text.
You too.
Tab, finish. So here's every picture that was taken. Here's a latitude and longitude for it. There's the altitude that it was taken, the altitude in WGS 84, and the heading, pitch, and roll. So if you need to take this data and you're wanting to use a piece of software other than Post-Flight Terra 3D, this is your geotag file that has every piece of information that you need to associate that photo to where the other software would stitch it different. I don't really know why you would, but if somebody's a Trimble user and they want to use their own software or maybe using a different aerial package, a different mosaic package, here's where you find that data to stitch everything together and use something other than Post-Flight Terra 3D. So I got the spinning wheel. Any other questions? No?
How do you reset a simulator to just run it one more time without having to reset your entire flight plan and everything?
Oh, okay. Hold on. Emotion 2. You have to save it. So if you want to use the same flight plan?
Mm-hmm.
Okay. So there's my little area down there again. Did you get any simulated errors there?
No, I haven't gotten any.
All right, 300 by
Although
500.
when the battery runs out on my simulation and I hit the recharge button, it still shows that it's empty battery, even though it's been recharged. That's the only thing I've noticed.
So if I hit upload and upload this flight plan to the plane, and then go back to the screen. It's the setup phase, has the little curly Q airplane looking symbols. I can say save flight plan to file and just call it demo. So if I exit out,
save it before you simulate it.
Hmm?
So save it before you run the simulation.
Yeah, we have to upload it and then save it. Yeah. So if I exit out of here and I go back into eMotion 2, I can connect to the simulator again. I can go right here and say, and it was called demo. I just loaded it from a file. There it is again. And to explain kind of the safety features of the plane, not to try to get carried away here, all the safety features of the flight of the plane are pretty neat. Any of this data that's in here, I can change in real time. This is even if the plane's in flight. If I want to make this flight line shorter or longer, I can edit it while the plane's in flight. If I want to change my landing spot, all I have to do is click on my little landing triangle, and I can move it over here, and then change the direction that the plane's going to land. This is its approach sector. Okay? And if the plane senses trees in its flight line or terrain, the optical ground sensor will make the plane avoid the ground. If you have more than one E-beat, we have crash avoidance. It knows the location of the second plane. It will actually avoid it. If we want the plane to come and land in the middle of a mission, all we have to do is click the land button, go land, and it'll come back and land. If we want to initiate an emergency sequence, we have to actually click this 3 times, but it goes down wherever the plane is in the flight.
It goes in that circular landing.
Yeah, the circular landing thing, which is I'd say you'd be real. I wouldn't do it. I just wouldn't recommend it. And here on the last tab,
Spare set of wings on.
There's the ignore RC signals. I like to leave that on and return home in case of strong wind. So if the wind gets too strong for the plane when it goes to make its turn on its waypoints, and if it becomes unstable, a lot of times it'll come back and land. If you're flying in a canyon and you got bad GPS coverage, the plane will come back and land. If the battery runs low, it comes home and lands. If the camera is unplugged, or if it's not in the auto or manual mode, if it's in auto mode, the plane will come home and land. If it loses radio link, I like to leave that turned on. The ground control station, your laptop, if it loses communication to the plane for more than 30 seconds, it will come home and land. If it
Is there a way to change that duration?
Nope. Nope. You can just leave it unchecked. It'll continue its flight. It'll just keep flying and taking.
Go with its program flight all the way through, and then follow all the way, and then reestablish once it gets near it again.
Yes, it will reconnect itself once it gets near it again. And if it senses the ground, it'll climb and avoid ground. And if you're trying to land and you want to use the ground sensor for landing, which is the default with it turned on, as the plane comes in on this approach sector, it'll start sensing where the ground is and use this landing spot as a 2D landing spot. And as it approaches, it'll continually lower itself, reverse its propulsion as it gets to its landing spot and touch down. That's a unique feature to our plane. The reverse propulsion thing is a really neat feature to be able to slow itself, and people refer to it as a crash landing. It's a controlled landing. It just lands on its belly. So that ground sensor aids in knowing where its landing spot, what its elevation is in reference to it, and how much it needs to slow itself down.
So don't try to catch it.
And try to catch it? Okay.
Yeah.
I caught one with my left
Can
hand.
you? Are you advised highly against that?
Well, there's a pitot tube that's on the top of the plane that measures the wind speed and altitude. It's for differential and absolute air pressure. And if you reach up and snag that and rip that pitot tube off, it's got to come in to be repaired.
Okay.
But I have caught it. I was talking to a customer with my phone in my right hand and caught it with my left as it was coming in to land. Just reached out and grabbed it. I have witnesses. I swear to it.
So, Chris, the plane is flying with is the plane flying with an autonomous GPS location?
Yes, it is. It's using GPS that's not much different than the GPS in your cell phone.
Okay, so So having said that, is there an opportunity, is there a post-processing where we're somewhere near some core station and we can get some real-time, we can get some post-processing, a base information? Is there a way we can reprocess that using that?
No, sir. It just uses the GPS for its autonomous flight direction, and we're in the photogrammetry world now, so adapting to that from the survey world, I know is probably, I had a tough time wrapping my head around that part. The GPS.
Well, one of the firms we work with, they do the same thing. I don't know if you ever heard of pictometry, but when we first started, with cameras and planes and GPS and IMUs and all that, we weren't very good at where we were on the face of the earth, but then when we were able to post-process it, we were able to tighten it up to a real-world solution that was a lot closer without the ground control. So what you're saying is we can't post-process this.
No, we have to rely strictly on ground control for precise orthomosaics.
And that's not something that's coming in the near future or anything you're even thinking about, right?
No, sir, and quite frankly, the GPS is just a code-only, small, no real antenna kind of thing, so that I can't imagine it's coming at any point. Like I said, it's in photogrammetry, it's where we use ground control. If we're in doing LiDAR, it's where we would use our GPS.
I understand that.
So, but no, it's all done by ground control, and the ground control procedure is fairly simple. Again, I always use a 3x or 4x4 painted X on the ground. That seems to work. That seems to work the best for me. And I generally make my stripe about 6 inches wide, maybe 3 passes each direction. Make it pretty bold, and then calibrate to it whenever I post process, and everything seems to come out really good. So, but no, as of right now, and I'm not even heard anything. I know what's coming down the pike as far as some options in the future, things that they're working on. I've heard thermal cameras are coming. I don't know when, but I know that they are coming. There's some NDVI cameras that are predicted to be in the future that are supposed to be pretty swanky. There is a homing beacon available for this guy. It's an expensive option. It's a radio transmitter. It's inside the body of the plane. So if you did a really long flight and it was really windy that day, and as the plane was coming back to land, you lost communication with it, the battery went dead or whatever, it'll allow you to go out and find a plane even though the plane has a dead battery. I mean, you always have the last GPS position that the plane was at, but you'll also have an FM radio frequency to help get you closer to it. So that's like a $1,500 option. I haven't needed it yet or had any customers to need it. There is an option. I found it online. It's for model rocketry. It's a little transmitter. It'll fit inside the body of the plane, but it emits a chirp. It's a pretty loud chirp. It helps model rocket builders find their model rockets after they land. The only thing is it's making that chirp the whole time it's in the air. And so wherever it's at flying, whatever it is directly underneath, it's going to hear that chirping. So, but it is an option. It's like $12 to get one. You can get them online. So, any other questions? Oh, and
typical landing width that you want when it's coming down.
The default
for linear landing.
I like to have a path. I've landed them in power line right-of-ways before. What I will tell you is you don't want to try to land it on a cliff, like where there's a big change in elevation between where the approach sector is and the landing spot. So if there's let's say a big deep pond right here in this triangle, and the plane's going to fly over it, it's using that ground sensor to make its approach. So if there's a big change in elevation, it might crash into the bank of the pond. Or if you're trying to land on a cliff, I know this from firsthand experience, if you're trying to land on a cliff, it'll crash right into the cliff because it's seeking the ground that's much lower than the cliff. Does that make sense? That video that we produced where it shows us on a cliff launching it, well, it crashed into that very same cliff. We don't show that part in the video. That was a learning experience. I had a customer report to me. It was on page 76 of the manual. Don't land on a cliff and use the ground sensor. So Learned a
Yeah,
lot.
I read that part yesterday.
Yeah, it's a good read. The manual is actually pretty decent material. Even though it is written by some Swiss guys, it's easily understood. But I didn't think it was hard to comprehend. It didn't seem to miss anything. So I don't know what else I can add. Hopefully on the next go round we have a new mine site that we collected some information on. And I'm sure we'll have some other projects, and I'll have some more data that's been captured using the oblique imagery option. So on the next forum, we should be able to cover some different data than what we just did in this one. So I don't know what
Are you
else.
going to have any of that information available for Tuesday?
No, I won't have a chance to go out and fly something. I'm pretty sure I won't. I'll try.
All right, no worries.
I'll try.
Don't miss any Super Bowl because of me.
Oh, on Sunday?
Yeah.
I keep forgetting it's the Super Bowl. I can't believe we're to that point of the year already. And being in West Virginia, we don't have any irons in the fire, so the Super Bowl gets left out. It's always college football for us. So,
I'm in New Mexico, so we just cheer for Colorado.
no. Well, if I were going to cheer for somebody, it's hard to not cheer for Peyton Manning, who's getting to be old for a quarterback, and I can appreciate a guy that has that much iron will to go out and get beat up every time. So, but anyhow, if there's nothing else, no other questions for me in the meanwhile, I'll adjourn, and I thank everybody for attending, and if anybody has any specific questions they'd like to ask or anything they need to address with me, you can drop me an email if I didn't cover it. If it comes to your mind later, just send me something. I'll be happy to respond to you. And there's a few of you I guess I'll be talking to next week. So that being said, I guess we'll adjourn. Everybody have a wonderful Friday, and I thank you for attending.
All right, thank you so much.
Thank you.
Thank you, Chris.